A sample of an element X was extracted from a meteoroid. The table gives the percentage abundance of the isotopes of X obtained from the mass spectrum of the sample. Calculate the relative atomic mass.
This is pretty easy. The 54 times 0.061 plus 56.
54 in 6.10.
No, 0.061.
But in the end, we will divide it once by 100, no?
Yeah,
50,
but then like if you just do it with the with decimals at first, it would be easier.
right, 57 into 1.9.
And then all divided by 100.
Is it this one?
Yeah, let's calculate it. Should be 55.9.
50?
5.9.
Identify X and hence give the numbers of subatomic particles present in the species at M upon E is 56. Now what this part means?
Which one? Could you go
Part number 2.
X? Hence giving the number of subatomic particles present in the species at ME56. Now we'd open the wait. So is it asking which okay, it's
Identify
diatomic.
X. I think we should keep the data booklet in front of us. Maybe we can guess someone on 56.
I think we can go periodic table as well. Could use that.
Please take out the periodic table.
Because 56, we're talking mass here, right? Or atomic number
The
here.
mass number.
Mass number, right? Okay. 56 would give us 55.9 is iron.
Very good.
Or actually it's 55.8, but like it's close
Say
enough.
mass spectrometry, should I say iron or should I say Fe plus 1?
Fe plus 1.
Good.
But it could be Fe plus 1. But like it could be something else as well, no? Like if we divide it by 2, let's say. Let's say 28. Could that be something?
But by
Like it
default,
could be it could be silicon plus 2, possibly.
by
I mean,
default, the charge in a mass spectrometer is always plus 1.
always plus 1. Okay.
Always.
Unless they say it's 2, right?
In the next unit, unit 2, you will see that there will be charges possible, but by now you have studied only M plus 1. Number of particles present in the species M upon E, you have identified it iron. So can you tell me the atomic number of iron?
Atomic number of iron is 26. So there's 30 neutrons, 26 electrons, and 26 protons.
Look at the basic working.
Yeah, that's just mass number minus the atomic number, then like 30, or neutron number.
Look at the answers. How we find neutrons?
They're neutrons.
A peak at m upon E is equal to 28 was also detected in the mass spectrum. Identify the species which produce this peak. 28.
Hmm.
If iron is the
Fe
main
plus
element,
2. Yeah, Fe plus 2.
only way to identify by default, it is always +1. But now it
Yeah,
is
but
having
then
8, which is exactly half of 56.
so Fe plus 2.
Explain why the 3 isotopes of X have the same chemical properties.
Because they have the same electronic structure, therefore they react and act the same way.
Three isotopes have accept the same chemical properties. Isotopes generally have same chemical properties or different. Chemical properties arise from number of
Electrons, basically.
outline how a solid sample of element X is converted into ions in a mass spectrometer. He's talking about some procedural question. This is a procedural question, 2 marks is giving. So do we vaporize the sample and then inject it in the solution?
Yeah, first is vaporized, and then it's passed through an area where it's bombarded with electrons, where it would gain its positive charge.
vaporization, and then high-speed electrons, and then following the formation of ions, there are 3 steps in the production of a spectrum in the mass spectrometer. Name the 3 steps in order and state how the first 2 are carried out. After the formation of ions, do we accelerate them?
Yeah,
After the formation of ions, we accelerate them.
they are put through 2 charge plates, which accelerate them to
And then
the
we deflect them in a
detector.
magnetic field.
Yeah, sorry, it deflects in a magnetic field and then gets detected.
Ah. We have an order of acceleration by an electric field, deflection by a magnetic field. Then the last step is detection. The element sodium and the compound sodium bromide are both solid at room temperature. Name the type of bonding in sodium and explain how this bonding holds the structure together. Sodium is a metal.
Yes.
So if I think sodium is a metal, metallic bonding, how this, how should I write after that? He is giving me 2 marks.
Basically, you have to say metallic bonding, and then you have to say metallic bonding is when there are positive ions and delocalized electrons that have electrostatic forces between them holding it together.
Yes, there is an assembly of positive ions surrounded by the famous word, surrounded by a sea of electrons. And electrostatic attraction between positive ions and negative electrons hold the structure together.
Yeah, electrostatic. Yeah, okay, that's written.
Name the type of bonding in sodium bromide. Explain how this bonding holds the structure together.
Hmm. In ionic bonding, wait, okay, so oh, it's one mark. Oh, okay, but then it's explained. Okay, in ionic bonding, there are giant ionic lattices, which is formed by the cation giving the anion its or basically donating its electrons to it, which
Yes,
then
it's a
forms
lattice
yeah, which then forms this giant lattice, which has intermolecular forces in between them.
intermolecular won't be a good word. Otherwise, other things are right. Remember,
Right,
sodium bromide is not a molecule. The word
Van der
molecule,
Waal.
remember the word molecule is restricted for covalent compounds.
Okay,
Ionic compounds are not molecules.
so Van der Waal forces.
Van der Waals forces can't be. Remember the
Hmm.
word you said earlier, electrostatic. That is the right.
Oh,
Remember,
okay,
Van der Waals forces are also designated for covalent molecules. So I'm using the first word you use because that is the right word. The table shows the melting temperature of sodium and of sodium bromide. The table shows the melting temperature of sodium and of sodium bromide.
There are
Sodium is
the
371 and sodium bromide is 1020.
so basically ionic bonding, electrostatic force of attraction, higher energy required
Are
to
very
break
strong
electrostatic
relatively.
forces. No, talking about sodium.
So he want a comment because already ionic and metallic we have already explained now. So we can tell examiner that look, melting point of sodium bromide is greater than melting point of sodium. Then what it means? It means that ionic bonding is stronger than metallic bonding in this case. Whenever we are doing past paper, I always advise my student that you should keep a as ionic letters. Ionic compounds are not a good conductor in their solid state. They are good conductor in molten state, but in solid, they are good insulator. So these are the questions in which you have to improve your answer quality so you can inshallah get a good result, because MCQs, I feel you're doing mashallah good, and you can improve your quality of answer. You obviously by the after the mock you can learn all the notes, and definitely language is required, the good language. Examiner report is very helpful. It can also, I have shown you that it shows poor answers. Sometimes you're writing an answer, you think it's good, but examiner report tells you, no, this is a poor answer. So for that purpose, it's a good idea to go and use examiner reports for at least some theory questions. Like this is a pure theory question. Ammonium ion contains covalent bonds and a dative covalent bond. Difference between a covalent and a dative bond, 2 marks.
In a covalent bond, both atoms, should I say, would both
Both
atoms would share an electron each. However, in a dative bond,
covalent bond, both
both atoms share an electron each. And then in covalent,
here.
sorry, in dative covalent, we would have one atom donating a pair of electrons,
Yes. Good.
not two,
Dative bond,
rather say pair.
one atom here, it can be an atom or 9 actually. One atom shares draw a dot and cross diagram for an ammonium ion. Use the symbol X for electrons from hydrogen atoms and dot for electrons from the outer shell of nitrogen atom. So he's talking about ammonium ion N1, 2, 3, 5. Look at this working.
Yeah. It's plus because H is plus. So the overall charge of the entire molecule will be plus, right?
How an electron density map of ammonium chloride would provide evidence for the presence of ions in the compound. Now, this is a bit tricky part. We have done this one, part 2, but part 3 is giving me 1 mark for it.
Basically, if there is less dispersion, it would show that there are ions, but then I don't know how to put in words.
How should I say that? Suggest how an electron density map of ammonium chloride.
Basically, if there is more distortion from the cation, it mean wait, no, if it's more distortion, would it mean it's uh, if it's less distortion, is it ions, or if it's more yeah, if it's less distortion, it's ions, right?
So we should make some ammonium and chloride, and we can make the ammonium ion is having, if we make an ammonium ion, ammonium chloride. So should we make ammonium chloride, or the lines are given, no space for drawing actually? How an electron density map of ammonium chloride would provide evidence for the presence of ions in the compound?
Basically, one of the hydrogens would have
No, I was thinking,
like
should we write a script here, or should we draw those density lines? Because these are ionic, this is an ionic compound. Now, ammonium chloride would be ionic. So I can make one circle for ammonium ion and second circle for chloride ions. So if I go for, let's say I decide to make up like this. This is what I draw here. Because I was thinking for these two things, and then we can make lines around it. Not very nice because it's a PDF. Second option, which I can use, the conventional model, is this one. So these are the two options.
mm, basically distortion, kind of. No? Is it to do with distortion or no? That's like
Yeah,
the
so
phenomena.
can you speak a bit loud? Couldn't get it.
Oh, sorry. Is it to do with a distortion or no?
No, no, no. It is not related with distortion because distortion won't occur here. Ammonium ion is too big. You're thinking in the right position. Polarization, that is right. But ammonium ion is actually bigger than chlorine. Ammonium ion is actually bigger than chlorine. So the real diagram is very difficult to make. If you have seen those diagrams in your school, that the distortion diagrams, but you can't combine them. Na? If the positive ion is a smaller, let me show you here. Suppose you draw aluminum chloride. So if you have a small aluminum like this plus 3 and you have a big chlorine, then you can draw these lines which you are thinking like this. Like this. For these ions, the circles won't combine. For these ions, circles won't combine.
Okay.
Ethane react with chlorine in the presence of ultraviolet light
Wait, could you
forming.
go back again? I was just noting it down. Uh, So it's like the worded explanation for this one, then. Like in
This is
words.
right. This is what I was thinking. Na? This ask you. Either we,
It's
because the question doesn't say any explanation, so we can write only this sentence, which is the evidence
no overall charge. Overlapping.
overlap.
Oh, wait, right. Yeah, because the electron density of each of them, there will be like space in between, which shows the okay.
Huh. Otherwise,
Okay.
the ion, when you form it, ions are always different. Ethane react with chlorine in the presence of ultraviolet forming chloroethane and other products. Ultraviolet light causes homolytic fission of chlorine molecule. Draw a dot and cross diagram of a chlorine molecule and use it to explain what happens to the molecule when homolytic fission occurs, naming the species produced.
Okay, I'll try drawing this one. And there's O X. Wait, no, what is X? O, L. And then half curly arrow, and then half curly arrow. That's L. Can I just draw it as a radical, or do I have to do the?
Radical,
Or do I have to like draw every single electron around it?
both atoms, both electron will go with one. Na? Or sorry, no,
Yeah,
both atoms will take up their electrons
it is
and
a
they
homolytic. That's why.
happily separate.
Oh, would this be fine then?
I think it's fine.
And then I would just write after that explaining that each chlorine atom takes one electron to form a free radical.
But he's asking for any explanation. I think he's just asking to
No,
draw.
he's like draw and then like explain,
But
no?
he has
No,
given, you're
explain.
right, but he has given some lines.
Yeah, that's what
Write
I
the
was.
equation for the two propagation steps which occur in the reaction producing chloroethane. Can you tell me any idea for this? Are you going to input? Are you going to tell me that what are the two the two propagation steps? As we were discussing in an MCQ, so suppose I say any two reactions are fine, any two equations are fine.
Yeah, I'm thinking like well, the first one would be CH4 plus Cl.
So if I take CH4 plus Cl like this,
Yeah,
this is one option.
yeah.
Then any other propagation step?
Another one would be basically after this CH3 radical forms, you do CH3 radical plus Cl2 gives you CH3Cl plus
Attack
HCl.
on chlorine. You want to attack on chlorine?
Hmm?
If you want to
Yeah,
attack this radical to go and attack
chlorine. Yeah.
this one, okay. Write the equation for the termination step which produces a hydrocarbon as a product in the reaction. Termination means two free radicals hit each other.
Again,
Termination
yeah,
means
two radicals react with each other. CH3 plus CH3 is C2H6.
ethene also reacts with chlorine, but by a different mechanism. Is he talking about electrophilic addition?
Um,
So he says how pi bond is formed. Why he has made a star on it?
Star would be marks for linking, right? I think that's what it was in the physics 6 marker at least. I'm not sure.
And you have to make a quality here. There is another star question.
Worded communication, word how you communicate the answer.
Quality of language.
Yeah.
So pi bond in ethane forms. You can tell that examiner, you can tell him that pi bond is formed by sideways overlap, sideways overlap of p orbitals. Why this bond causes ethene to take part in addition reaction? They can be attacked by
The radicals or, well,
electrophile. No?
electrophiles, yeah.
This is not a job of radical, electrophile.
Okay.
Pi bond at this point breaks. Addition occurs. Write the mechanism for the reaction of ethene with chlorine. Use curly arrows to show movement of electron pairs.
Yeah, that'll just be Cl plus S and minus S, and then
Base is very limited,
yeah, that's true.
very strange. I thought maybe it's a reprint. Let's see the actual paper. They should be space. Hopefully, you're writing with me for a revision.
Yeah, I've written already.
You have done it.
Yeah.
Showing all the sets, the curly arrows, especially.
Yeah, the curly arrows,
Of the reaction of chlorine with ethene.
carbocations. Yeah. Okay.
And the final product would be chloroethane. Na? 1,2-dichloroethane.
Yes. Because it's, yeah, 1,2-dichloro.
Okay, now look at this one. I'm just coming. Look at this part, C part. Write a balance equation for the polymerization of 1-chloroethene to PVC.
Yeah, for this one, I just, well,
Bracket
turned
one.
1-chloroethene, yeah, just bracket and then N.
First,
I
we
see,
made
see that,
1-chloroethene and then N on the left side. That one.
yeah.
After the reaction, it will be is this.
Yeah, turned into that.
So we stop here and we will inshallah continue this in our next class.
Okay,
Allah
that is.